So let's use the method of completing the square to solve this equation here. Now it's not going to factor, right? I mean, what are you going to use for 10? 10 and 1? You can't get an 8 out of that. What about a 5 and a 2? You can't get an 8 out of that. 5 and 2, you get a 7 or a 3. So this is not going to solve by factoring, so we need another method, and our method is going to be completing the square. So here's how this goes. The first thing we're going to do is we're going to separate. We're going to get the variables on one side and the constant on the other. So let's get rid of this 10. Let's add 10 to each side. This is going to give us x squared plus 8x, I'm going to leave it blank here, equals, now if I add 10 to both sides, it's gone from the left and it shows up on the right. Right? So I get x squared plus 8x equals 10. Now I want to turn these two terms into three terms. I'm going to add something right here that's going to make this trinomial a perfect square trinomial. So this one here is going to factor like this, something squared equaling, okay, well let's get this first and then we'll see what we're going to put over here. We know the pattern, right? We square the first, so what do you square to get x? Squared, you get x. Now, according to the pattern, you multiply these two together and you double it. Now, if you do that, you're going to get 8x. What would we multiply here? What would we put here so that when I multiply and double, I get 8x? Well, half of 8 is 4. Half of plus 8 is plus 4. So we're putting a plus 4 here. But then if we keep going, you square this one, right? So you square this one. So what you're going to get is 16. So I'm going to rewrite this now. So we're really going to put a 16 over here. So I'm going to write it like this, though. I'm going to write it as x squared plus 8x. Now, if I keep going, I square that, 4, so I get 16 equals 10. But be careful now, because what we did is we added, see what we did here? There's the original. We added 16 to that left side. So to keep this balanced, we have to add that 16 over here to the right side. So we are going to get a plus 16 over here. This factor is just like this. This is just what we produced. We forced it to happen. Equals 26. And we know how to do these problems. We were doing these in the last section. So we have quantity squared equals some number. So let's unsquare. Let's take square root. So what we're going to get here is the square root of quantity x plus 4 squared equals square root 26. And on the left side now, the square root of the square gives us the absolute value of x plus 4 equals, now that 26, I think we're just going to be stuck with that. I don't think we can break that one down anymore, so we'll get square root 26, absolute value there. Now, remove the absolute value. This is where we get plus or minus. And now we can solve for x, right? We can solve for x by subtracting that 4. So let's do that. Subtract 4, it'll look like this. X equals negative 4 plus or minus square root of 26. That doesn't look like a 26, does it? So let's write a 26 here. Okay, there's our solutions. And if we want to write it like the book's probably asking us to in terms of solution set, we would write it, okay, there's our opener, negative 4 minus square root of 26, negative 4 plus square root of 26. There's our two solutions. Let's move on to number 23. We've got x squared minus 6x equals negative 12. Now what we could do, of course, is quadratic, so we're thinking, oh, I'll get everything on the left side and try to factor this. Everything on the left is 0 on the right and try to factor it. But this is not going to factor. How would you factor 12 to get a 6? 12 and 1 doesn't do it. 4 and 3 doesn't do it. 2 and 6 doesn't do it. So this equation is not factorable. So let's use the method of completing the square. So we have the variables isolated on the left already. We just need to add that magic term over here. So let's do that. What I want is for this to factor, I want to add something out here, right? Add some term so that we get this. X, something squared, right? I know it's going to be an x because what do I square to get x squared? Okay, now what do we put here? Well, look what we've got. What do you multiply together to get you negative 6x? Right, so we multiply together and we double, and we get negative 6. Well, what did you double to get negative 6? You doubled a minus 3. But if we keep going, then you square the first, getting the x squared, multiply these together, negative 3x, double it, gives you negative 6x, but then you have to square the last. So if you square the last, you're really adding in a plus 9. So I'm going to write what we've got then. We will have this. We'll have x squared minus 6x plus 9, right, if we actually run this through. But look up here, there's no 9 here. So I'm adding a 9 to the left side. To keep it balanced, we have to add that 9 to the right side. So we're going to have that this is equal to negative 12 plus 9. Now the left side we know factors like this because we just forced it to do that. X minus 3 squared equals negative 12 plus 9 is negative 3. And we've solved quite a few of these. We know what to do. We'll take the square root over here. So we'll get the square root of the quantity x minus 3 squared equals square root of negative 3. On the left side, the square root of the square is the absolute value of x minus 3 equals, now we've got the square root of negative, take the I out. Square root of 3, we can't simplify that. But now, let's remove the absolute value. So we'll get x minus 3 equals, now we get plus or minus I square roots of 3. And one more step. All we have to do is add 3. So it's going to look like this. We'll get x equals 3 plus or minus I square roots of 3. Okay, there's really our two solutions. But it's likely that the textbook wants us to write our solutions in a solution set. So we're going to get 3 minus I square root of 3 and 3 plus I square root of 3. Quadratic equation, we're expecting two solutions, and there they are.